Good day everyone, I am Shane Marita Gem Turkey and today's lesson video is about area measurement using Planimeter and Simpsons method. But before we dig this lesson, let us first test your knowledge in this short motivation, which is the true or false. So in this scenario, I want you to read silently and I will give you 10 seconds to answer these questions. Are you ready? Let's start. Alright, time's up. So all of your answers are correct. So 1, 2, and 3 are all true, while number 4 is false. And now you already have the knowledge about what will be our lesson for today. First, we have the objectives. So, distinguish the use of Planimeter and Simpsons method. To recognize the different methods in using Planimeter and Simpsons method, and understand and learn how to use these methods in area measurements. The first method is Planimeter, also known as platometer. It is a measuring instrument used to determine the area of a two-dimensional shape, and it is a tabletop instrument for measuring areas, usually the areas of irregular regions or map or photography. And there are two types of planimeter. We have the polar planimeter and the linear planimeter. As you can see in the picture, they are different from each other. The two planimeters differ in the movement of the end of the tracer arm opposite to the tracer point, and I will explain that one by one. So let's have first the linear planimeter. So that ends is restricted to move along a straight line from the word linear. The drawing suggests that it runs along a track, but a more common way to cause this motion to move this end attached to a set of wheels that are fixed to an axis so that the wheels turn together. While the polar planimeter, the end opposite the tracer point, is restricted to move along a circle. From the word circumferential, this is done by making that the point, which is the hinge between the tracer arm and a secondary arm, one end of which the pole is fixed. According to my research, polar planimeter is commonly used. Why? Because polar planimeter is restricted by design to measuring areas within units determined by its sides. Unlike linear type has no restriction in one dimension because it can roll. Its wheels must not slip because the movement is be constrained to have a straight line. And now let's move on to the various components of a planimeter. So we have here the tracing arm. Tracing arm is an arm which manages the position of tracing point at one end with the help of hinge. Tracing point is the movable needle point which is connected to tracing arm. This point is moved over the outline of area to be measured. We also have the anchor arm. It's used to manage the anchor position or needle point position on the plan. It is one end is connected to weight and needle point and other end to the integrating unit. Then we have the weight and the needle point. It is also called as anchor. A fine needle point is located at the base of the heavy block. This needle point is anchored at required station on the plan. Clamp. It is used to fix the tracing arm in standard length without any extension. Hinge. The tracing arm and anchor arm are connected by hinge to the integrating unit. With the help of this hinge, the arms can rotate about their axis. We have tangent screw. It is used to extend the tracing arm to the required length. We have here the index. It is a location where all the measuring arrangements like wheel, dial are located. We also have wheel. Wheel is fixed in the integrating unit which helps to measure the tracing length. It is used to set zero on the scale. We have here the dial. Dial is nothing but scale which is to be set zero at the initial level using setting wheel. And lastly, the vernier. It is attached to the wheel as rounded drum with graduation on it. It is divided into 100 parts. So that's the various components of a planimeter. This picture is an example on how to measure an area using a polar planimeter. But to fully understand what is polar planimeter or planimeter, I have here a short video. Another method in area measurement is the Simpsons rule. It's used to find the value of a definite integral by approximating the area under the graph of the function of the f and x. When using Riemann sum, we calculate the area under a curve by dividing the area under the curve into rectangles, whereas while using Simpson's rule, we evaluate the area under a curve is by dividing the total area into parabolas. This figure represents as a parabolic rule. So Simpson's rule, the boundaries between the ends of ordinates are assumed to form an arc of parabola. In this rule, we have the three consecutive ordinates, the 0, 1, 0, 2, and 0, 3. Then we have d, the common distance between the ordinates, and the area AFEDC is equal to the area of the trapezium AFDC plus area of segment FEDEF. So here is the step-by-step to get the area between the first two divisions. So we have the area of trapezium, the area of the segment, then we get the first two divisions, which is the area of 1 is equal to 0 sub 1 plus 0 sub 3 over 2 times 2d plus 2 over 3 times close open parentheses 0 sub 2 minus 0 sub 1 plus 0 sub 3 over 2 close open parentheses times 2d. So the area of the next two divisions is area of 2 is equal to v over 3. Then we have 0, 1 plus 4, 0, 2 plus 0, 3, and so on. Take note that we are referring to the figure that I present to you. So the total area is this, or what we see. So we have here the common distance is over 3, which is the first ordinate plus the last ordinate, plus 4 from sum of even ordinates, and plus 2 of sum of remaining odd ordinates. I will show you here. Now let's have the area of measurement. So to the sum of the first and the last ordinate, 4 times the sum of even ordinates and twice the sum of the remaining odd ordinates are added. This total sum is multiplied by the common distance. 1/3 of this product is the required area. Here we will total the area. See, the common distance is d is equal to 25. Then the area is d over 3. Then 0 sub 1 plus 0 sub 7 plus 2, then 0 sub 3 plus 0 sub 5 plus 4, 0 sub 2 plus 0 4 plus 0 sub 6. Is equal to 25 over 3, open parentheses, 3.6 plus 4 plus 2, open parentheses, plus 6.5 plus 7.3 close parentheses, plus 4, open parentheses, plus 5 plus 5.5 plus 6 close parentheses. So in all, the total area is 843.33 square meter. This rule is only applicable when the numbers of divisions is even. The ordinate is odd, so that gives more accurate result. Another term of Simpson's rule is one-third rule. So this rule is one of the most popular methods of finding the area for a given set of points by the method of numerical integration. The basic idea is to divide the x-axis into equally spaced division as shown, and to complete the top of these strips of an area in such a way that we can calculate the area by adding up these strips. So as you can see here, the P1, P2, P3, P4, P5, the Y1, Y2, Y3, Y4, and Y5. Then we have the A, H, and B. So in this one-third rule, the important points to be considered while applying this rule is the number of interval must be an even number, and minimum of 3 points are required, then intervals are expected to be equal. So here we have the example. Take a look deep this example. We have some labels and then we will go through about it. We have here the cutting area first. We have the easting, the initial level, the final level, and the cutting depth. And we have here the calculation of an area of square meters by using Simpson's 1/3 rule. So the formula of this h over 3, the first value plus the last value plus 4 times sum of the odd values plus 2 times sum of the even values. So here h is equal to, as you can see, the 21 over 3 is equal to 3 is equal to 3 over 3 open parentheses, then we have the 0.70 plus 0 plus 4 times 0.5 plus 2 times 0.1. In all, if you total that, the total is 2.9 in cutting area. After the cutting area, we have the filling area. Also have the easting, initial level, final level, cutting depth, and the calculation of area square meters by using Simpson's 1/3 rule. So h over 3 first value plus the last value plus 4 times sum of odd values plus 2 times sum of even values. So here it is the h is equal to 21 over 3 is equal to 3. So is equal to 3 over 3 open parentheses plus 0 plus 1 plus 4 times 1.1 plus 2 times 0.4 is equal to 6.6. Fully understood, so we have here the summary table of some of the cutting and filling that we use the Simpsons 1/3 rule. So we have here the section 80, the trapezoidal method. We have the cutting and filling. Then we have the net area, also include the cutting and filling. Then also the Simpsons rule, which is the result, which is the 2.9 in cutting, and in filling is 6.6. In order for you to understand how to use Simpson's rule, then we have here workout problems. Problem 1. The following offsets were taken from a chain line to an irregular boundary line at an interval of 10 meters. So we have here the 0, 2.50, 3.50, 5.00, then 4.60, 3.20, then 0m. So compute the area between the chain line, the irregular boundary line, and the end of offsets by. So here the distance is 10 meters. The required area is equal to 10 over 3. Then we have here the 0 plus 0 plus 4. Then we have 2.50 plus 5.00 plus 3.20 plus 2 plus 3.50 plus 4.60. So is equal to 10 over 3 open parentheses 42.80 plus 16.20 close parentheses is equal to 10 over 3 times 59. So the total is 59. We have already the result, which is the 59.00. So in this scenario, we have to work out this. 10 over 3 times 59 is the result, or the answer is 196.66 meters squared. So that's the compute between the area between the chain line and the irregular boundary line and the ends of offsets by using the Simpsons rule. For more information and knowledgeable ideas about this method, kindly visit these references. Thank you and God bless.